Hello friend, last we complete exercise 9.3. Now here we discuss about sum to n terms of special series. Sum to n terms for special series. First 1 plus 2 plus 3 plus up to plus n. Remember this here. This is the sum of first n natural number. And we know about this sum of from 1 to n natural number. Already we discussed this type of formula in principle of mathematical induction. We know that 1 plus 2 plus 3 plus up to n is equal to n plus 1 by 2. You know. Remember this here. 1 plus 2 plus 3 plus up to plus n. Sum from 1 to n. Sum of a natural number from 1 to n is also denoted by sigma I or sigma k. K is equal to 1 to n. And in short is also denoted by here last number n. So also denoted by sigma n. So remember this sigma k equal to 1 to n, or sigma n is equal to n plus 1 by 2. Remember this formula, important formula. Similarly, for special sequence 1 square plus 2 square plus 3 square plus up to plus n square is equal to, it denoted by sigma k square. K is equal to 1 to n, and also in a short form denoted by sigma n square. Sigma n square is equal to, remember this formula, n plus 1 to n plus 1 by 2. Clear? Most important formula, sigma n square, or sigma k equal to 1 to n, sigma k square k equal to 1 to n. And the last important formula, 1 raised to 3 plus 2 raised to 3 plus 3 raised to 3 plus up to plus n raised to 3 is equal to, in a summation form, sigma k raised to 3, k is equal to 1 to n is equal to, also in short form, sigma n raised to 3. And the formula of this is equal to square of sigma n. Square of sigma n is a n square, n plus 1 square upon 2 square is a 4. Clear? So remember this formula, sigma n is equal to n plus 1 by 2. Sigma n square is equal to n plus 1 into 2n plus 1 by 2. And sigma n cube is equal to square of first n square n plus 1 square upon 4. Clear? In all, n plus 1 by 2 is common. Clear? Remember this, n plus 1 by 2. In the sigma n square, only multiply with 2n plus 1. And sigma n cube multiply with the same number, n plus 1 upon 2 square, there are 2, that is a n square, n plus 1 square upon 2 square, that is a 4. Okay. Now here we discuss solution of exercise question, exercise 9.4. First question. Question number first. Find the sum of n terms of series in exercise 1 to 7. First question, 1 into 2 plus 2 into 3 plus 3 into 4 plus up to plus n term. In this type of series, first we find n terms. Here first term is equal to 1 into 2. Second term is equal to 2 into 3. and third term is equal to 3 into 4. Let n term is an is equal to, take in the first bracket first term of each, 1, 2, 3 up to n term, into in second bracket take a second terms of each, 2 plus 3, 4 up to n term. Now 1, 2, 3 up to n terms of this is equal to, we know that how to find. Here first term is equal to 1. To find n terms, n minus 1 into d, common difference, 2 minus 1, that is 1. Here 3 minus 2, that is 1, that is 1. Clear? Into same for this first term is a 2 plus n minus 1 into common difference is a 1. Okay, so is equal to, now simplify this, n minus 1 plus 1, that is n, into here n minus 1 plus 2 become plus 1. Clear? So is equal to n square plus n. So n terms is a n square plus a n. Therefore sum of n terms, Sn is equal to 1 into 2 plus 2 into 3 plus 3 into 4 plus up to plus n square plus a n. Okay, is equal to sigma n square, or in this form write first, k equal to 1 to n, replace n by k square plus a k. Clear? So is equal to, now sigma apply to both. So is equal to sigma k square, k equal to 1 to n, plus sigma k is equal to 1 to n. And we know that sigma k square, k equal to 1 to n, is equal to n plus 1 to n plus 1 by 6, plus sigma k equal to 1 to n is equal to n plus 1 by 2. Clear? So is equal to n plus 1 by 2 take common. So here n plus 1 by 2 into bracket, here remaining terms 2n plus 1 by 3 plus 1. Okay, so is equal to n plus 1 by 2 into 3 take LCM. So 2n plus 1 plus 3 become 2n plus 4 upon 3. Now simplification, 2 take outside, so 2 cancel, we get n plus 1 n plus 2 by 3. Clear? Answer. Now next question, number 2. Find the sum of n terms, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus up to plus. First find n terms. Let an is equal to, take a first term of each in a first bracket, first term of each terms in a first bracket, 1, 2, 3 up to n time, into in a second bracket take a second terms of each terms, 2, 3, 4 up to n times, into now in a third bracket take a third terms, 2, 3, 4, 5 up to. Clear? So is equal to n term of this is equal to, we know that here n terms of this is a 1 plus n minus 1 into 1 plus into here n terms of second bracket is a, here first term is a 2 plus n minus 1 into common difference is 1 into in a third bracket first term a is equal to 3 plus n minus 1 into 1. Clear? So is equal to, now minus 1 plus 1 cancel, we get n. Here n minus 1 plus 2 becomes n plus 1. Here n minus 1 plus 3 becomes n plus 2. Clear? So n plus 1, n plus 2. Okay, this become n terms of this summation. Now sum of all n terms Sn is equal to sigma an. So is equal to sigma n is equal to, we know that n plus 1, n plus 2. Okay, and n plus 1, n plus 2 is equal to n into splinter both bracket n square plus 3n plus 2. Now n take inside, we get sigma n raised to 3 plus 3n square plus 2n. Clear? 2n. And apply sigma to both. Here we get sigma n cube plus 3 sigma n square plus 2 into sigma n. And we know that sigma n cube is equal to n square n plus 1 square upon 4. 2 square is a 4. 3 into sigma n square is equal to, here sigma n square. Sigma n square is equal to n plus 1 2n plus 1 by 6 plus 2 into sigma n is equal to 2 into n plus 1 by 2. So is equal to, now simplification, here n plus 1 by 2 from all take common. So we get n plus 1 by 2 into bracket, here remaining terms n plus 1 by 2 plus here 3 upon 2. 3 upon 6, that is 1 by 2. Here n plus 1 by 2 take common, so remaining term 2n plus 1. 2n plus 1. Now from this n plus 1 by 2 take common, so remaining term plus 2 only. Clear? Now simplify this. So n plus 1 by 2 into, here 2 take LCM, so 2n plus 3, n take inside parallel to this, so we get n square, n plus 2n into 2 become 4n, 2 plus 1, 3 into 2 become plus 6. Clear? So is equal to n plus 1, here n square plus 5n plus 6. Clear? Upon 2. Okay, answer. Or get into factor form. 6 divide 6 would sum become 5. 3 into 2. So we get n plus 1, n plus 2, n plus 3 upon 2. Clear? Answer. Here upon 2 given, so 2 into 2 become 4. So here 4. Clear? This is final answer. Now question number 3. Find the sum of 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus up to plus. First find the n terms. Let an is equal to, here first term is 3, 5, 7. So in the first bracket write 3, 5, 7 up to n term into, now in the second bracket 1 square, 2 square, 3 square up to n term. So is equal to, now find the n terms of our first sequence. Here first term is a 3 plus n minus 1 into common difference is equal to 2 bracket over into here n terms of this is a n share, clear, given 1 share, 2 share, 3 share up to n share. So is equal to, here 2 take inside, 2n minus 2 plus 3, that is become 2n plus 1 and n share, clear, n is equal to n share 2n plus 1. Now sum of n terms Sn is equal to, we know that sigma an, and an is equal to, we have n share take inside, so 2n raised to 3 plus n share, clear. Now sigma apply to all, so 2 into sigma n cube plus sigma n share, so is equal to sigma n cube is equal to, we know that share of n plus 1 upon 2 share, so n share n plus 1 share upon 2 share is a 4 plus sigma n share is equal to n plus 1 to n plus 1 by 6, so is equal to, here n plus 1 upon 2 from both take common, so n plus 1 by 2 in bracket remaining terms, here 4 upon 2 become 2, so remaining term becomes n plus 1 plus here n plus 1 by 2 take common, so remaining terms 2n plus 1 by 3, clear. So is equal to, here 3n take inside, so we get n plus 1 by 2 into 3n share plus 3n plus 2n plus 1 upon 3, clear. So is equal to n plus 1 into 3n share plus here 5n plus 1 upon 3 to 6, okay, 3n share 3n plus 2 5n plus 1 upon 6. Now question number 4, find the sum of 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus up to plus. Here find n terms, directly get the sum of all terms. Let Sn is equal to 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus up to plus n term and term. So is equal to, here 1 upon 1 into 2 change into form of 1 upon 1 minus 1 upon 2, clear, plus same 1 upon 2 minus 1 upon 3, okay, plus 1 upon 3 minus 1 upon 4, applying same, last term n terms is equal to 1 upon n and 1 upon n plus 1, clear, bracket 1, because here in a first bracket 1, then second bracket second terms 1 plus 1 2, same here in second bracket first term 2, then second terms 2 plus 1 3, so in a last bracket first term n in denominator, then in a second terms denominator is n plus 1. Now minus 1 by 2 plus 1 by 2 cancel, same minus 1 by 3 plus 1 by 3 cancel, so remaining terms become 1 upon 1, that is the first term of first bracket, and the last term of second last bracket, 1 upon 1 minus 1 upon n plus 1. Now take LCM, n plus 1 minus 1 upon n plus 1, so is equal to, here minus 1 plus 1 cancel, we get a n upon n plus 1. Okay, this become sum of all n terms. Now question number next, 5 raised to 2 plus 6 raised to 2 plus 7 raised to 2 plus up to plus 20 raised to 2. Here first find the n terms of a sequence. Let n is equal to 5, 6, 7 up to n term. So n terms of this is equal to, here a first term is equal to 5 plus n minus 1 into common difference is equal to 6 minus 5, that is 1. So is equal to n minus 1 plus 5 becomes n plus 4. Therefore sum of n terms Sn is equal to, we know that sigma, here this is for an, so is equal to sigma n is equal to n plus 4. Clear? So is equal to sigma n is equal to, we know that n plus 1 by 2 plus 4 into sigma 1, and we know that sigma 1 is equal to n. So sigma 4 into n. So is equal to, here 4 take LCM, we get and n take inside, or n take common with n upon 2 take common. N upon 2 take common, so back in first terms n plus 1, here 4 into 2 becomes 8 and take a common. Clear? So is equal to n, here n plus 9 upon 2. Okay, answer. Same question number 6, solve yourself. Find the sum of 3 into 8 plus 6 into 11 plus 9 into 14 up to infinity. Similarly, in a 7, 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus up to plus. In this case, here first find the n terms. Here an is equal to 1 square plus 2 square plus 3 square plus up to plus n square. So is equal to sum of n terms is equal to, we know that n plus 1 to n plus 1 by 6 sigma n square. We know that 1 square, 2 square, 3 square up to n square is equal to sigma n square, and sigma n square is equal to n plus 1 to n plus 1 by 6. Now split all bracket, so we get n, here 2n into n becomes 2n square, n into 1 and 2n into 1 becomes 2n plus 1 3n plus 1 into 1 become 1 upon 6. Clear? Now and take inside, so an is equal to 2n square n cube plus 3n square plus n upon 6. Clear? Therefore sum of all term Sn is equal to sigma an, we know that. So is equal to sigma an is equal to, we have 2n raised to 3 plus 3n square plus n upon 6. So is equal to, now 1 upon 6 take outside, into bracket 2n raised to 3 becomes 2 into sigma n cube plus 3 into sigma n square plus sigma n. Clear? Sigma apply to each. So 1 upon 6 into 2 into sigma n cube is equal to, we know that n square n plus 1 square upon 4 plus 3 into sigma n square is equal to n plus 1 to n plus 1 by 6. Okay, and sigma n is equal to n plus 1 by 2. Now simplify this here. N plus 1 upon 2, from each take common. So here 1 by 6 into n plus 1 upon 2 take common, n plus 1 by 2 take common. So in bracket remaining terms, here n plus 1 n plus 1 upon here 2 cancel, plus here n plus 1 upon 2 take common, so remaining terms 2n plus 1 upon 3 cancel, that is a 1, plus here n plus 1 by 2 take common, that is a 1. Okay, so is equal to n plus 1 by 12 into here n take inside, so we get n square plus n plus 2n plus 2. Clear? So is equal to n plus 1 and n square 2n plus n becomes a 3n plus a 2. Clear? Upon 12. So is equal to here divide 2, both sum become 3. So n plus 1, here n plus 3, sorry 2 and n plus 1. 2 1 is a 2, 2 plus 1 3, that is n plus 2, n plus 1. So this become n plus 1 square n plus 2 upon 12. Okay, 12. Answer. Now question number 8. Find the sum of n terms of series whose n terms is given. Here n terms n is equal to n plus 1, n plus 4 given. Now look here. First split both bracket, n into here becomes n square, 1n plus 4n become 5n, that is n square plus 5n plus 4. Clear? So is equal to n take inside, so we get n raised to 3 plus 5n plus 4n. Bharat? Therefore sum of all term Sn is equal to, we know that sigma an, and sigma an is equal to n cube plus 5n plus 4n. Clear? So is equal to sigma n cube is equal to, we know n square n plus 1 square upon 4 plus 5 into sigma n is equal to n plus 1 by 2 plus here n square. Clear? So n square is equal to n plus 1 to n plus 1 by 6, and 4 sigma n is equal to n plus 1 by 2. Clear? So is equal to n plus 1 by 2 take common, so n plus 1 by 2 take common, so in bracket remaining term n plus 1 by 2 plus here 5 into n plus 1 by 2 take common, so 2n plus 1 by here 2 take common from 6, so 3 plus here n plus 1 by 2 take common, so 4. Clear? Now here 3 to 6 take LCM, so we get n plus 1 into bracket and take inside parallel to this, and 3 to 6 take LCM, so 3 into n take inside, so 3n square plus 3n. Clear? Here multiply with 2 2 into 5 become 10. 10 take inside. So 10 to 20 and plus 10 plus 1 again. So 10 plus here 6 into 4 24 upon 6. Here 2 already given. Now simplify this n plus 1 and 3n square. Term with the square only 1. 3n plus 20n becomes plus 23n plus here becomes 34 upon 6 into 2 becomes 12. Clear? Now question number 9. Here n terms n is equal to n square plus 2 raised to n cube. So find the sum of n terms. Therefore Sn is equal to sigma an. We know that sum of n terms. And the sigma an is equal to, we have n square plus 2 raised to n. So is equal to sigma applied to both sigma n square plus sigma 2 raised to n. And the sigma n square is equal to, we know that n plus 1 to n plus 1 by 6 plus sigma 2 raised to n is equal to 2 raised to 1 plus 2 raised to 2 plus up to plus 2 raised to n. Clear? So is equal to n plus 1 to n plus 1 by 6 plus, and this is a sum of geometric sequence, geometric progression. Both first term is a 2. Common ratio is equal to 2 square upon 2, that is a 2 raised to n minus 1 upon 2 minus 1. We know that Sn is equal to a into r raised to n minus 1 upon r minus 1. Clear? Here 2 minus 1, that is becomes a 1. So answer is equal to n plus 1 to n plus 1 by 6 plus here 2 into 2 raised to n minus 1 upon a 1. Clear? Or 2 take inside, so 2 raised to n plus 1 minus 2. This is the answer. Okay. Now last question 10. Here n terms n is equal to 2n minus 1 raised to 2 given, that is 4n square minus 4n plus 1. Now find the sum of n terms. So Sn is equal to sigma an, and the sigma an is equal to, we have 4n square minus 4n plus 1. Clear? So is equal to sigma applied to each, 4 into sigma n square minus 4 into sigma n plus sigma 1. So 4 into sigma n square is equal to, we know that n plus 1 to n plus 1 by 6 minus 4 into sigma n is equal to n plus 1 by 2 plus sigma 1 is equal to n. So is equal to n plus 1 upon 2 take common. Here n upon 2 only take common. Okay. Or simplify first. 2 to 4, 3 to 6, here 2. So n by 3 take common. N by 3 take common. So in bracket remaining terms 2 into n plus 1 to n plus 1. Here n by 3 take common. So here becomes minus 6 into n plus 1. Okay, 1 by 3 take common, that is multiply by 3, and n take outside. So 3 to 6 n plus 1 plus, here n take common and the 3 take LCM, that is 3. So is equal to n by 3 into 2, split of both bracket, we get 2 into 2n square plus n plus 2n become 3n plus 1 minus 6 take inside, so 6n minus 6 plus 3. Clear? So is equal to n by 3 into 2 take inside, so 4n square plus 3 to 6n plus 2 minus 6n, here minus 6 plus 3 becomes 3 minus. So is equal to n by 3, here 4n square, 6n plus minus cancel, minus 3 plus 1 become minus 1. Clear? Answer. Here in your book given 2n minus 1, 2n plus 1. This is factor of 4n square minus 1. Clear? n minus 1 and 2n plus 1. Okay, this is the final answer. This is also correct answer. Now in next lecture we solve question of miscellaneous exercise. Okay.